Let's go to start our topic, four-stroke diesel cycle. The subject is basic of mechanical engineering, and today's lecture we have to study about the four-stroke diesel cycle, also called as a compressed ignition. Why we have to say is a compressed ignition? Because of that, the ignition take place inside the cylinder. Why? Higher pressure and the ignition are take place inside cylinder with a self ignition where is the pressure and temperature is very high, so it's called as a compressed ignition. In this cycle, using working fuel as a diesel. First we have to know the history about the four-stroke diesel cycle. It is invented in 1819 in Germany by Rudolf Diesel. In the name of the Rudolf Diesel, we have to say is a diesel cycle. Is the surname of by the scientist Rudolf. It is invented by him. It is invented because of the efficiency of steam power engine is very less, nearby 10% efficient. Steam power are produced by the steam engine, and then after the steam engine give the higher pressurized and temperature steam, and this steam we have to using and converting into the mechanical work, but the efficiency level for the steam engine is very low, nearby the 10%. So the scientist Rudolf Diesel invent a four-stroke diesel cycle. It is the internal combustion engine similar to gasoline powered engine. Both are the gasoline powered engine and diesel powered engine are same as a internal combustion engine. This cycle also called as a compression ignition because of the compressed ignition are take place inside the cylinder. Usually there is the two types of the cycle are available, four stroke and sometimes we have to using a two stroke cycle for diesel engine. Mostly we have to using a four stroke cycle because of it is a efficient working. Here the image we have to shown in the animation image working in a four-stroke cycle. By we have to using as a working fluid is diesel. This portion known as a inlet port. The gas are inlet from the cylinder inside. Then after the compression, and this portion are called as a fuel injector. This fuel injector are inject the fluid inside the cylinder and take place ignition itself and came outside from the cylinder at the final stroke. Is the animation file for working of diesel cycle. Then after we have to show the another working part. An engine which are combustion process start with air fuel mixture and self-ignited due to the higher temperature inside the combustion chamber and causes by the higher compression. Whenever the compression stroke are start, the second stroke called as a compression stroke is taking a very high pressure inside the cylinder. Also same parallelly temperature also is increasing. Whenever we do inject the fuel inside the cylinder, it can ignited by itself due to the higher pressure and temperature, and it create a higher compression and produce a power stroke. Spark ignition and compression ignition engine are operate on either four-stroke cycle or two-stroke cycle. Both of the SI engine and CI engine available in four-stroke cycle and two-stroke cycle as per the requirement. For an four-stroke cycle, it has a four piston stroke over two revolution per each cycle. And for a two-stroke cycle, it has a piston two-stroke over a one revolution per each cycle. It means that the movement of piston in a four-stroke cycle, it's move four times. It's a four-stroke cycle, move four times, and two times it create one revolution. Then after the another two types of two-stroke move up and down position and creating a one another revolution. So it's called as a movement of piston is 4 times and creating a 2 revolution for a 4-stroke cycle. For a 2-stroke cycle, only 2 revolution and 2 stroke and 1 revolution per cycle. When we will dealing with the compression ignition operating on 4-stroke cycle by using of diesel as a working fluid. For any types of the compression ignition, always working fluid used as a diesel for an completing cycle. Let's we have to now show the working of 4-stroke diesel cycle. First, we have to know the component part of the all piston cylinder or crankcase arrangement. This part called as a crankcase. This part called as a flywheel. This part called as a connecting rod. This portion called as a piston. This circular inside the piston called as a connecting rod of piston pin. This 3 horizontal white line called as a piston ring. The working for piston ring. Let's give a one type of the sealing. The pressure are not transferred from bottom side to down, bottom side to top side and top side to bottom side of the cylinder. This portion called as a cylinder. This portion called as a inside cylinder. First portion just we have to show in here is called as a intake valve, and this another valve called as a outlet or exhaust valve. This line called as a fuel injector. The meaning for a fuel injector is inject the fuel inside the cylinder to complete working of cycle. For a first stroke, it's called as a suction or induction stroke. At this time, the piston move from its top dead center to bottom dead center. Here, the piston move from its top dead center to bottom dead center. What happened at this time? The volume are increasing. The first volume we have to show it here. The first volume is that lower, and then after the piston move from its top dead center to bottom dead center, the volume are increasing. What this time happen? It's creating a vacuum inside the cylinder. Whenever the piston move from its top dead center to bottom dead center, at this time the inlet valve are open and outlet valve are closed, so that the air are enter into the cylinder. For a diesel cycle, only and only air are inletted at this point. For a petrol engine, air and fuel mixture are enter at the point of inlet. And for a diesel cycle, only and only are air inlet inside the cylinder. Then after the another stroke, second stroke, called as a compression stroke. The second stroke called as a compression stroke. At this time, the piston move from its bottom dead center to top dead center. What happened at this time? The air is sequenced as a piston move from its bottom dead center to top dead center and reaching about pressure likely to 40 bar. Whenever the piston move from its position bottom dead center to top dead center, it's heavily pressurized the air, likely to 40 bar pressure. 40 bar pressure is a very high pressure. At this time, the pressure increased and parallelly temperature is also increasing. The pressure and temperature is very high about this inside cylinder when we have to compress the stroke. The air gets very hot about to 700 centigrade because of the work done by it the piston. Piston compress the air and the pressure are increasing, parallelly temperature increasing up to the 700 bar. Diesel fuel is started to injected into the cylinder as the piston get near to top. When the piston reach at the top dead center, means we have to highlight here. If the piston, this position called as a top dead center, and piston reach at this position, the fuel injector are inject the fuel inside at this point. Here the fuel are injected start when the piston near at the top dead center. The injection started before the piston reach at the top dead center. Next we have to show the third stroke. Third stroke we have to show here. This called as a power stroke. Third stroke called as a power stroke. Both the valve inlet and outlet are closed. Both valve of the inlet and outlet are closed. Fuel is injected into the cylinder for the short while as the piston is near at TDC center. For a power stroke, we have to start the fuel injection inside the cylinder. First, we have to draw some diagram. Here, this point called as a top dead center and this point called as a bottom dead center. When the piston are moved from bottom dead center to top dead center at this level, what happened at this time? The piston are near about the reaching the top dead center. When piston reach at this point, the fuel are started to injected inside the cylinder. When piston are completely reach at the top dead center, the fuel completely injected into the cylinder. At higher pressure and higher temperature, the fuel are spray and ignited to burn into the hot air. The temperature of the air is nearby 700 centigrade and pressure is up to 40 bar pressure. When we have to inject the fuel inside the cylinder, it takes place self ignition with the presence of air and creating a higher pressure and temperature inside the cylinder. This portion called as a self ignition take place inside the cylinder. At this time creating a higher pressure and higher temperature, and it gives a maximum thrust on the piston. Then after the piston move into the downward direction when the ignition are take place complete inside the cylinder. This pressure of the hot gases push the piston downward and delivering power to the crankshaft to flywheel. When the highly force the piston move downward direction, the force are coming from piston to connecting rod and connecting rod to flywheel, and flywheel are move from its position to circulating motion, and it's delivering equal power to another stroke. What happen whenever the power stroke are completed? It's getting a maximum energy from the power stroke on flywheel and equally distribute to another stroke like as a exhaust stroke, compression stroke, and suction stroke. Then after the last fourth stroke called as a exhaust stroke. The exhaust valve are open and the piston move from its bottom dead center to top dead center. The exhaust stroke are started at this time. The inlet valve are closed and outlet valve are open. Whenever the piston move from its bottom dead center to top dead center. What happened at this time? The gases are producing by the combustion is take place outside of the cylinder. Here the piston push the burnt gases out of the cylinder. When the piston gets near at top dead center at the exhaust stroke, the valve are closed and inlet valve are open. When the piston move from its bottom dead center to top dead center, the exhaust valve are open. When it's reached as a top dead center, the exhaust valve are closed and inlet valve are open to ready the drawn fresh air in the again for a next cycle. Whenever the next cycle is start, the piston moves from its top dead center to bottom dead center and creating a vacuum. Let's have to see in a whole figure in a one drawing. Here the first figure called as the intake, inlet valve are open, exhaust valve are closed. At this time, new air passes inside the cylinder and piston movement is downward direction. Then after the compression stroke are start, the piston movement is upward direction and the both valve of the inlet and outlet are closed. Then after the third is a power stroke. Power stroke for an at this time what happened? The fuel are injected by the fuel injector and the highly thrust are created inside the cylinder and piston move the downward direction called as a power stroke. Maximum power are generated in this stroke. Then after the piston move from its bottom dead center to top dead center and exhaust gases are coming out from the cylinder. When the piston move at the top dead center, exhaust are closed and inlet valve are open and repeat cycle to first to a intake stroke. Here we have to show an animation file for working of 4-stroke diesel. So we have to start it from first point. The suction stroke is started, intake, the fuel air are drawn into the cylinder. Then after compression stroke are start. Here the fuel are injected, intake ignition itself and creating a power stroke. And then after the piston move again in upward direction and exhaust gases are coming out from the cylinder. This is the working of 4-stroke diesel cycle. This bottom side cool edge is a oil sump is giving a lubricating to all mechanical and moving part. So thus there we have to removing some of the noise, vibration, friction, wear and tear. So that's what oil are required for the all types of the engine. Let's have to see the diagram for 4-stroke diesel cycle. Here the diagram are mentioned in a pressure versus volume. This A point called as a starting of the cycle. A, B, C and D and D2 written A. First the point P0 to A. Just we have to mention with the drawing. Here P0 to A. That's point are called as a suction where the fuel or air are take place inside the cylinder. Then after compression stroke is start. Compression stroke means we have to compress the air. So from point A to B, we have to compression stroke. That's called as a adiabatic compression. Here the relation between pressure and volume is PA divided by PB. A means 0.1, B means 0.2, C means 0.3, and D means 0.4. And we have to equal to volume difference like as a higher volume divided by lower volume raised to gamma. Then after process B to C, Q1 means heat addition. Here is the ignition are take place inside the cylinder. Then after the piston move from its top dead center to bottom dead center, that's called as a power stroke from position C to position D. At this time, the pressure difference is equal to volume difference. Pressure difference is PD, higher pressure divided by lower pressure, is equal to volume, higher volume divided by lower volume raised to gamma. Then after the exhaust stroke from D to A, at this time we have to remove heat or exhaust gases from the cylinder. That's called as a Q2. Here we have to removing heat and exhaust gases, and Q1 we have to creating a heat inside the cylinder. We have to call as a ignition. Here is a diagram for 4-stroke diesel cycle, pressure versus volume. Okay, thank you.